continuing to the section or topic 2.1, and we're going to look at the tangent line problem. So we're going to explore the tangent line a little bit here. So we're going to begin with the graph of y equals f of x. So this is a function. And we're going to begin with an arbitrary point on the graph. We're going to call that point c f of c. So you can see it already plotted on the graph over here. Then let's choose another point on the curve and that has a horizontal distance of change of x units to our initial value c. So I'm just going to pick another point, and I'm going to label that point x f of x. Place this point in curve preferably close to the right edge. Connect those points. Okay, so we're going to connect the points. And it's asking us what is the slope of the secant line joining these 2 points. So remember, our slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to go with my second point first. So my slope would be f of x minus f of c over x minus c, because this would be my x sub 2 and my x sub 1. Now it says, now just for kicks, let's let our second x value from above move closer to the original value, reposition the point so it's about halfway as close. Okay, so I'm going to change it to here. So this is now my x, f of x, and connect the 2 points. And we do have a little gap in there, so do we still see a secant line? And I would say yes, we do still see a secant line. Is there any difference in its slope? So let's calculate the slope. So my y2 would be f of x, my y1 would be f of c, and then we would have x minus c. So is there any difference when we calculate the slope? That's a big fat no, right? All right, step 3. So since we are having such a blast moving our second x value closer to c, let's move the x value so that it almost touches c. So we're going to reposition it right there, and it's going to be x f of x. All right, so that it lies right next to c and connect the 2 points. So I'm connecting right there. Do we still have a secant line? Yeah, technically we do. So yes. How could we perceive the slope now using a very important concept from Unit 1? So basically, if we're thinking about what's going on here, we're getting closer and closer and closer to being a tangent line. And when we get closer and closer and closer, what we are doing is finding a limit. So the limit or the slope of a tangent line, I could have labeled these secant lines. This is just a little subscript, it's notation, just to say, hey, that's the slope of a secant, this is the slope of a tangent. As x approaches c, we have not an equal sign. F of x minus f of c over x minus c. So that's the official definition of a tangent line with slope m, is that formula that we just created.